Okay, so yeah, as we mentioned on Tuesday, Patrick pointed out, for the production of the Hopskotch sort of suite of software, we've been using Scrum, which is a form of agile software development. And in that, I'm acting as the Scrum Master, and Mario Juric, or is it Juric? It's Juric, I guess. I should know that. Juric is acting as the product owner. I should remind you as well that we are recording and that this will end up on YouTube, including my mispronunciation of Mario's surname. And Mario is going to start with some introductions and then lay out how the rest of this is going to go. So I'll hand over to Mario now.
Yeah, thanks, Adam. My name is Mario Juric. I'm a professor at University of Washington astronomy and the director of our Juric Institute for Data Science and Astronomy. And I will just start with a very brief introduction and kind of frame the demos that are about to follow, and then I hand it over to the team who will show you Hopskotch functionality. Before we begin with talking about Hopskotch, I just wanted to briefly go over a couple of technical Zoom details. Most of us have spent our lives on Zoom over the last 3 months and know this already, but if you're using something different and Zoom is not familiar to you, one of the things we're going to be asking you a lot is to confirm that you've reached a certain point in a demo by raising your hand or by clicking yes, or maybe to ask a question by raising your hand and confirm you reached a certain point in a demo by clicking yes. So this video that I recorded yesterday during the IAM session shows you how to do that on Zoom. Simply click on participants. That's going to bring up a participant list, and then you have these buttons down here, down below that you can click on to indicate that you either have a question by raising a hand or that you've completed the task so far, if you click yes. So if any of that is unclear, please do let us know in the chat, and we'll try to help you one-on-one. So with that out of the way, I'm introducing this, but this has been, everything we're going to show you has been a product of this fantastic team that actually just started working on all of this a little over 2.5 months ago. We have a team that spans both coasts and 3 time zones that we manage in the Scrum process every 2 weeks with new features, new increments. Shereen ElSayed and Bryce Cousins are going to lead the demos today, but this has really been a team effort for everything that's been produced, including the demo itself. So I really do want to acknowledge this group that's done this fantastic work over the last couple of months on an extremely tight schedule. Let's talk about Hopskotch. So what is it, and what are we trying to do with it? So the way I think about Hopskotch is that it's a multi-purpose, reliable, scalable pub subsystem. And what does that mean? It is a bunch of buzzwords. What that means is that what we're trying to do is build a system that allows an arbitrary number of people or projects to send and receive an arbitrary number of messages, irrespective of what those messages are. We'll get to that in a second. Then to an arbitrary number of receivers, with all of that with authentication so that it's clear who sent which message and when, with authorization so it's clear who is allowed to see a message, with no loss. This is extremely important. So we have a requirement here that no messages get dropped, and with low latency. And when I say arbitrary here, what that really means is that the system should be scalable to some reasonable scale that we expect to see in MMA astronomy and in observational astronomy in general over the next 5 to 10 years. And this seems fairly straightforward. If you're like message passing seems fairly straightforward, right? I can write a program that's going to send a message to another program, but when you take all these requirements into account, when you also take into account that these projects are sometimes on different continents, you discover that this is actually really, really hard. So we have strong delivery guarantees. Nothing must be dropped. For certain projects, we're going to have high throughput, more than, for example, ZTF sends around more than 1 million messages per night, and we need to be able to scale to that as necessary. There are going to be many clients, from perhaps a few clients at the beginning, then to potentially thousands of clients in the end. The system has to scale to that. I already mentioned that we expect clients to be even on different continents. One of the projects that we have a relationship with and good discussions with is IceCube, which is on Antarctica. Potentially, we might be talking about that kind of geographic separation. It has to be resilient. So if your Wi-Fi is flaky and your laptop or your machine drops off of the net for a couple of seconds, when it reconnects, it should be able to receive all the messages that have been sent in the meantime. So no losing of messages. Same thing about if your machine goes down, or if one of our machines goes down, there should be resilience in there. And on top of all of that, it should be reliable. So this entire system should not go down, because if it does become a major contribution to the community or something that the community relies on, then you really cannot allow it to go down frequently. Other things to consider, existing legacy protocols. So we might need to support, this is not the first time that somebody thought of message passing in astronomy or event alerting. There are many protocols out there. We may need to understand how to transition, how to provide some transition from older protocols to what we're building. As Rich has mentioned yesterday, one might want to use different backends for different situations. So what we're going to show you here is built on Kafka, but there are situations where Kafka is too heavyweight. And what you'd like to do is to still be able to utilize similar APIs, similar code, if Python is still, for example, good, lightweight enough, even if the backend changes. One of the big things that we realize is that astronomy is not equivalent to the industry. Projects are often done by, especially at the exploratory phase, are often done by graduate students who do not have necessarily the expertise to deploy these kinds of systems themselves. So we need to find a way to make the interface to these systems, not the systems themselves, but the interface, the API, accessible to your domain scientist, rather than expecting there to be a software engineer to always help. And that leads us to strong Python support as well. So when you take all this into account, you realize that this is a difficult problem, and this is why we need a group of people to think about this and actually try to do something about it. And if we had to do all of this by ourselves, this would be a completely insolvable problem if we did this as a group of astronomers. These are serious computer science questions that we're tackling, especially in this regime. So that led us to not trying to reinvent the wheel, come up with another X4 astronomy project, but to really try to build as much as possible on industry standard solutions for these sorts of problems, and then add simple, thin usability abstraction layers, Python abstraction layers over them to handle this area of the problem space. So this is kind of a motivation of why this project and why we're building what we're building, and also sort of a division of what we get by adopting solutions from the outside, and what are the things that we need to add to make these solutions usable to astronomers. So let me move on to this slide, and then we're going to go to the demos. Let me explain the basic concepts around Hopskotch. So I said what we want to enable is message passing. And the way to think about it is we have a service. We have a server that exposes a number of message queues, and these are in our terminology and the Kafka terminology where we inherited from. They're called topics. So you can post a message to any of those topics, and others can read them from those topics. You can think of this as Slack on steroids, if you will, where topics are channels. What are messages? Messages can be anything. Hopskotch treats them as opaque blobs. By convention, we prefer JSON at the moment, but that's simply a convention that two clients can agree on. What is it they're transmitting as a message? These messages can be anything such as ATELs, ZTF alerts. They could even be messages about where a telescope is pointing. So something that you want to pass, that you want to make public to others, or within your research group. One or more users can publish messages to topics. So you can have an arbitrary number of publishers to any given topics and an arbitrary number of subscribers to any given topic. So by subscribing a topic, you start receiving messages that you and or others have published to that topic. So those are the two things that we're going to see demonstrated in the demo: how to publish a message to a topic and how to subscribe to topics to receive messages that others have published. The messages are guaranteed to be delivered at least once. This is a very strong guarantee that Kafka allows us to have, but note the careful language that I use here. At least once doesn't mean once. It means that in case of certain types of failures and so forth, you might get a message more than once. But it is so that's something that on the client side one needs to defend against. But it's that we feel that that's much better failure mode than receiving a message, than not receiving a message in the first place. All users are authenticated, so we know who sent the messages, and you know who, and we also know who's receiving messages. And also, we're not going to demonstrate that. We'll actually disable it for this demo to make things run smoothly at this early stage. But access to all these topics can be restricted. So there's strong authorization that we can impose to make sure that only the people who are allowed to see certain messages can see them. So these are the things that we're going to, that Shereen and Bryce are going to show you in the demos. We're going to have two demos. One will be about getting started with Hopskotch. This is going to be very simple, just installing Hopskotch and sending and receiving messages from the command line. So purely command line driven. And then in the second part, we're going to lead you through building your first Hopskotch enabled application. We're going to build a simple Python Hopskotch to email message bridge, which will essentially allow you to receive emails whenever a new message is sent. Before I hand it off to Shereen and Bryce, just a warning and a plea, really. Keep in mind that what you're looking at is rapidly evolving, but it's still alpha quality code. It's really aimed at future first adopters, and we're going to ask you to imagine many things that are going to be here in 3 to 6 months. This also means that hiccups are likely, and we apologize in advance if not everything runs smoothly, but we still hope that you'll get a good feel for what the system enables and will enable as we continue developing it over the next year or so. All right, so that was a very fast run through of what you're going to see, and now it's the demo time. So I'd like to hand it off to Shereen and Bryce, and maybe while Bryce is sharing his screen, take 1 or 2 questions.
Remember, you just raise your hand for questions that you want to speak out loud for everyone to hear.
All right.
Well, I have one question then, Mario. I know the answer, but other people might be interested. So if you were to give the sort of general shape of the roadmap that we're moving towards over the next 3 to 6 months, like in 2 or 3 sentences, what would you say? You're muted.
Sorry about that. I was saying that we're going to get back to that right after the demo. I have 2 more slides left. With the roadmap.
Oh, right. Sorry. Yeah.
But yeah, in general, it's adding authentication authorization, making it more user-friendly, and really deploying it as a still prototype but production level service. We'll get back to that after the demos.
Okay.
And then we can discuss that and ask for feedback, actually.
Yeah.
All right, handing it over to you, Bryce.
Okay, great. So I'm Bryce. I'm one of the developers at Penn State for Hopskotch. I'm going to be walking you through the first chunk of the demo, where we'll be looking at the Hop client and installing. So first thing, I'm going to send out a link, which you may have already received an email. This is just a walkthrough of the different commands that we'll be going through for the install, and I have it down here as well for copying and pasting, so just to make sure that all the commands that you run are free of typos. So with that being said, let's go ahead and jump in. So first things first, Hopskotch briefly is, as Mario mentioned, a Python package that's designed to manage message passing using Kafka. It does this by sending messages through a publish function and receiving messages by subscribing. And so what this is at the core is how Hop Client manages messages. And so in this demo, we'll be going through the installation of the Python package and how to use it for publishing, subscribing, the topics to see how the message passing works at this stage. And then we'll be applying and extending the existing package to a little use case. And so with that, let's begin. To begin, you will have to have some prereqs. As mentioned in the email, for Linux and Mac, you'll need Python and either pip or conda, as well as curl installed. We won't be going through the installation for those instructions. For Windows, you will need the Windows subsystem for Linux with those same prereqs. And so to begin with, let's just start with the installation. So for the demo, we'll be going with a virtual environment just to make this in a clean install. So when we're installing the package and its dependencies, we don't want to interfere with your native Python install and your own custom packages. So we'll just be setting this as a virtual environment. So to do that, first, go ahead and make a new directory and enter into that directory. And this will allow us to keep the virtual environment contained. And you can do this either with pip or conda. I'll be going through with pip, but conda works just as well with Python 3.7. So we'll create the virtual environment, and that will create its own directory. And so once that's set up, we can go ahead and with the actual install of the package. And that can be done through either pip or conda. Again, it's on both the Anaconda and Python package index repositories, which are at the top of the command script. So you can look at the source code from there and on GitHub. And
we should
so
probably give people a chance to create their virtual EMs.
Yeah.
If you've created your virtual environment, just hit yes as a reaction, just so we have some idea of whether everything is working well.
Sorry, the S function. What?
Oh, sorry. Yes. In the Zoom chat, there are reaction buttons at the bottom, so you can just hit the yes button.
Creates a green tick or check, I guess they call it.
And at any point, if something's not working, use the no or raise hand, and we'll have one of the developers help you with troubleshooting if there's an issue with the install for the package at some point. As well as you can use the go faster or go slower for pacing. So I'm seeing lots of yeses, no nos. And if you have any general questions, send it in chat as well. So going ahead, we can install the Hop client into the virtual environment. It'll download dependencies and install. And we can confirm the install by checking the help. And so once you're ready, you should be able to see just the basic entry point commands for Hop if it's installed properly. And so if you have a proper install, we can then move on to the next requirements. So for the current setup, we have a basic configuration file which has your authentication username and password so that we can connect to the Kafka service. And so we can download that with curl. That'll dump that into the current directory. And the other file we'll need is the example message that we'll be passing around. And again, curl that into the directory. And what that is a basic GCN circular message announcing a gamma ray status. And so this is just going to be the basic message that we'll be passing around as an example of what an observatory could be sending out.
Bryce, I think that Warren has his hand up. Do you have a question, Warren?
Actually, it was a failure that I'm asking for help.
It's a build failure. We can.
Okay.
Yeah.
All right, we'll do it in side channel.
Okay. So could we get a check with yeses, nos on everyone's status if you have the two files? Okay. Seen lots of yeses, so we'll go on. So what we have is now the publish and subscribe as we saw in the help. For the message passing, first we'll need to send it, so we'll use the publish function. So if you type hop publish help, you'll see some of the basic arguments that we have for the command. Central to this is the URL that we'll be talking to. This is the Kafka service that's currently hosted on AWS that we'll be talking to send and receive messages from. And this is why we need that configuration file with a username password to authenticate to. And next, of course, is the message that we want to pass. And there are a few other arguments that we'll go over. So to practice publishing a message, we will use publish, talk to a specific URL, and then create our own topic. And the topic, as Mario mentioned, is the kind of central message manager for Kafka. In this example, you can specify your own custom topic in this format. Doing user will create one for your username. And what this will do is create a topic that you can access exclusively. And
There was a
Yeah,
question
yeah.
on whether we can make fonts a bit larger in the term.
Make fonts larger. I don't know if I have the Zoom expertise to do that.
I think it's more in the terminal itself.
Let's see. I'm not technical for this, so I can answer your question with a solid maybe. Let's see quickly, unless someone knows.
I think control plus and control minus might work, right?
Control minus, I don't believe I have that in my profile. Yeah. Ah, that's resizing. Okay. Is that any better? Great, okay. So as before, we're just going to talk to the Kafka server and pass it, pass the client the F to specify the configuration file, and then finally just the example message that we want to send. And so when we enter, that will send off the message to the server and return us the terminal. And now we want to talk to that Kafka server again, this time with a subscribe. And so again, we're going to talk to it on that same URL and the same topic. And there are a few other command line options here. Again, passing the config, but what we're going to do differently is give it an earliest flag. And what this tells Hop is to talk to the server at the earliest possible message. And what this does is give you a historical view of all the messages in the topic. So since we just created this topic ourselves, there will only be one message, but if this is like an established topic with lots of announcements, you'll be able to scrape all of them with this one command. So when we enter that, we receive the message. And the Hop will wait the default 10 seconds before timing out and giving us back the terminal. So that's the basic example of seeing what a message being passed and then received looks like with this Kafka server. And so that's good as an example, but one application that we can do is continuously read from a topic, and that allows us to get new messages as they come in. Answering the question, is there an equivalent to a Kafka topic list in Hop? Currently not. We don't have a list of topics, I believe.
I think that's something that we will be adding as a feature. Yeah, Mara just said it will be a good feature.
Yeah.
A quick question also, if there's a second. Is there a way to know what time was received, the message was received by Kafka, so that you can tell if there's a pipeline, or I mean a log of all messages, you know which ones may be old?
Yes.
I can answer
Go
that
ahead.
a little bit. It doesn't exist in any of the tooling that we provide. In other words, the Hop client doesn't expose that, but the information is in fact stored within the Kafka broker. So that's likely something that we will add, is the ability to provide a little bit more visibility into those timestamps.
Okay, great.
Yeah, and keeping timestamps for the order, sorry, the time at which things arrive at the Hopskotch server is one of the things in our roadmap. That's definitely something we're going to do.
Yeah, so the data is there. Okay, so next, what we'll want to do is sit and wait on a topic and subscribe to it and just wait for new messages to come in. And so we can do that with the next command, where we're specifying the timeout here to be a little bit longer so that we can see events as they come in. And we'll make sure that you're going to the different topic, MMA announcement, as this has events that are coming in actively. And so Hop will just wait. And this is a potential use case where you have a user waiting to see events coming in from an observatory that's sending out trigger alerts. And you can have a user waiting as a follow-up observatory to try and see announcements as they come in. And so we had one. This is another GCN circular. This one is for the binary neutron star merger last year. And so this is just like a basic example of what can come in. You can have a client sitting and waiting and ready to act on an alert as it gets published by a triggering observatory.
So one thing that might be worth mentioning is that the client here displays GCNs the way we're used to looking at them as mail messages, but internally they're actually sent as JSON packets with headers parsed and the content of the message being a separate field of its own. So when we talk about there being a client sitting and waiting for these messages, that client can actually go and do something intelligent on them rather than have to worry about the parsing of them, etc.
Okay. And so another check just to see, are people good with status so far? Yeses and nos. And I make sure we have some raised hands.
So I see a raised hand by Ryan Fisher, and then Gabe Cobb.
Yep. Hi. I had a question about the single message kind of subscription. So I did the post to my own topic, which I made up my name, just RF. And then when I do the single message subscribe, I got it back. And then if I do it again, if I just keep repeating that, sometimes you get nothing. And then sometimes you just get the same one, which was the previous one. Is there a reason why you get nothing sometimes?
What's your timeout? Are you changing the timeout at all?
No, I'm using the single message subscribe one, the one that the first example, not the continuous timeout like the one you're doing with the GCNs that you're looking at now. The one where it ends in a -e, that query you put in the tutorial.
Oh. Yeah, I'm not sure. It returns without printing.
Sometimes.
-e should is an alias for -- earliest. So it should actually still print as many messages as it can find, and it will go to the beginning of the topic. If you're going to the same topic and repeated tries at that don't give the same result, then probably what's happening is some timeout. This is a lot more users than our Kafka server had yesterday, and it's entirely possible that it's getting sad. But I would expect that multiple invocations, if you give them long enough, should do the same thing with -- earliest or with -e.
Yeah, I was just repeating it to learn how it works because I assumed it would just always get the earliest one and then it stopped getting them. I was like, maybe there's like a queue that I'm like it's repeatedly publishing or something, but I didn't know. There should just be one message sitting there that I published, and then that's the one that it should always grab. Okay, got it.
That's right. Yeah, so you can play with that by specifying the timeout to be like 20 seconds or whatever you want, and that way you may be able to pull that message repeatedly.
Deep has a hand up there.
Hi. So I was wondering, suppose you start a listener and that is a subscriber, and suppose you stopped the subscriber for a certain time, and in between that time there were probably 10 or 20 messages or possibly 100 messages published. And after a while you turn back the subscriber on again, then is there a way by which you can, skip over the, say, end messages in the queue? Or is it that you always listen to the earliest, that is the first one in the queue, the one that you did not listen to?
I can try to answer that one too. When you subscribe, Kafka has a notion of consumer identifiers. And when you're subscribing, it's maintaining for your consumer's ID. It's maintaining a record of your position within that topic. So when you return, you'll come back at the same spot. This is a feature we haven't really exposed with the Hop subscribe client at this time, because the process of managing those client identifiers could be is just a little bit more than we're willing to handle in a demo like this. But the feature exists there to maintain a record of where you are in the stream underneath Kafka.
I see. And by default, it should go back to the last unread message.
That is correct.
Okay.
Okay. Eric, question?
Yeah, a follow-up question on that. I mean, it sounds like though that can be reset, and you can start getting another copy of a message you may have already dealt with or processed, right? So if I'm spawning a processor, or am I supposed to also be doing the bookkeeping of I've already gotten that message ID as well and reacted to it properly? Or is that intended to be kind of built into may not be in the command line client, but in some sort of, default client that, handles that record keeping of, I got one copy and only one copy and you've acted on it, thank you?
Yeah, at a low level in the Python libraries, there's a notion of committing your position within the stream. So you say, I have read up to message 110 or whatever, and you commit that, storing it in the Kafka broker, and Hopskotch will maintain that for you. Now it's kind of up to you to decide when to commit. If you're building an arbitrarily complex application, you might have really peculiar requirements about when you want to declare a message fully processed, and we can't necessarily make that call for you. So some of the low-level libraries will expose that kind of fine-grained control, if that answers your question.
And there will also be an archive with a public API that will be deduplicated. It will have one and only one copy of everything that went through Hopskotch that's available to people with your sub-authorization.
Maybe to directly answer Eric's question, right now the answer is no. So Kafka does not, or Hopskotch does not guarantee that you'll receive every message exactly once. So you might see it more than once, and therefore, if your processing relies on never processing the same message twice, you would need to somehow record that in your end. There is a mode. This is a relatively new addition to Kafka to allow for what's called exactly once delivery, but we have to look into whether that's safe to enable. But the main thing we're defending against here is that something gets dropped on the floor. That seems to be more serious than if you occasionally get it twice.
Quick question: does this have the ability? I'm thinking sort of in a database transaction kind of thing. If I have received a message and then something goes wrong on my end, can I mark something unread? Can I put it back on my stack is the point.
Yeah, no. So thinking again in terms of database transactions, once you say the equivalent, like literally it's called commit. Once you run commit, it's considered that you have processed it and everything went well on your side. So that's.
You can receive it without committing, is that correct?
Exactly.
Okay, as long as there's a way to, I can try that, go through all the logic, and if something failed on my end, I can fail out and still get the message later once I fix it.
Yeah, exactly. The idea is that
Right.
if you experience a crash of any kind before you've committed, the system will assume that you have not processed those messages. It will send them again.
Yeah.
Okay, another hand from Deep.
Yeah, sorry. I was wondering on the term commit. So since with Kafka, the message is delivered at least once, which means it can be delivered more than once. Is there a chance that after you have committed, you can still receive the same message?
I'd have to think about that, but I think the answer is yes, because potentially, when you indicate that you want to commit, I don't believe that Kafka actually signals whether it committed your offset. So potentially, if you say commit and then there's a network issue right after, like the millisecond after that, you might think that you've committed, yet Kafka has not recorded it. So there is the way we're running it right now. I think if you want to make sure that you don't process the same message twice, then storing some kind of message IDs on the client end would be required.
Thank you.
And I think this is useful feedback for us because we haven't explored this. We haven't gone very deeply into this exactly once mode of operation that Kafka does allow. But if this seems to be like a major issue for the community, then this can quickly rise on our list of priorities to look into.
I'm not sure about the exactly once business, because even if you implemented that in Kafka, you could still have publishers sending multiple versions of a particular event. And so I do think it's on the subscriber to keep an eye out for that sort of happenstance.
Yeah, I think in a very deep, like computer science distributed systems sort of sense, true exact once delivery is impossible. And so subscribers who want to be fastidiously careful about this should keep track in case of any sort of network shenanigans, especially.
Great. Okay. So if we're all good to go, we can proceed with the next chunk of the session. And so what we've seen so far is a mini application of subscribing to a topic and seeing what happens when we get an event coming in. And ultimately, we want to be able to receive that event and then do something about it, transform it, parse it, throw it through a neural network, do something with it. And so we're still in early stages, but one way that we're preparing for the next steps is by making the Hop client available as a app template, so it can be easily extended so that we can create parsers, transformers to do something with the messages next. And so what we're going to do now is talk about an email app with Hop client.
Shereen is muted if.
Go ahead, Shereen.
Okay. Sorry for that. So it's me, Shereen. I'm a software developer and researcher at UCSB. I'm working with SCIMMA. So after we have seen the Hop client and how we can use it to publish and subscribe to topics using Kafka, we will use Hop client to create a customized application using our Hop app template. The application that we are going to present today can be a real-life application if it needed to be. We are going to create an app that subscribes to a certain topic, and when it receives a message, it will send an email to you with this message. So the first thing we need to do is to install something called Cookie Cutter in the same directory that we have been working on. The recommended way to install Cookie Cutter is through pip, as mentioned in their own beta docs. But of course, it can be installed using other ways. I'm going to install it here. Just to make sure it's installed. For instance, we can try the dash version or help. Next, we will use Cookie Cutter to create an application using the template here. So for the name of the app, I'm going to call my application email, and I hope everyone calls it email as well, because I'm going to download some files that works if your application for now is called email. But of course, if you want to try this after the demo, you can call it whatever you want. The description can be anything. I can skip this for now if you wish. And the author name can be, for instance, Shereen. And author email, we can skip it. You can skip whatever you want of these parameters. And then if I checked here for the directories, I'm going to find Hop email app. So everyone is following. Are there any problems so far? Okay. So here in this directory, we can see the list of directories we have here. We will see docs. Bryce, if you can please get me the Visual Studio code. Okay, thank you. So this is the hierarchy of the directories we have here. You can find the docs where you can make your own documentations, and it's ready to be used for Sphinx, to be built with Sphinx. You can build it directly using the makefile here, and it's ready to be used. The Hop directory is where all your source code is going to reside later, and we are going to play it here in the main and the example files. Test is where all your test points, of course, will reside here. You have the make file as well. It's ready to go for your test to run, linting, formatting, building your own docs. And the setup to Pi, it's created and customized for your own application. Bryce, can you please close out the studio? Any questions so far? Okay, so I'm going to run some commands here just to change the code in the main and example. And get them. Okay. So the first file, I'm going to copy the main file, download using curl, and the second file is the example.py. So I'd like to show you what we currently have in main file. Bryce, can you get me Visual Studio again? Sorry. Okay. So the main file is actually very simple. I just added very small work here just to add my own command, the subscribe command with -f as you have seen in the normal subscription. And I just added -e for emails because we are going to add our emails where we are going to receive the message when Kafka sends it. And in the example.py, first I'm going to use the subscribe from the Hop client to use all its parameters and options. And I'm going to add here my email parameter. Sorry. Here I'm going to prepare my message, and then I'm going to send the email where I created a Gmail here account and using password for only applications, where you are going to receive the email. And finally, sorry about this. Finally here, if you can see the last 3 lines, this is actually code you only need to subscribe for a certain topic through Kafka. So the first one is the URL for Kafka, and then we are going to read, and then setting the format. Here we are going to JSON format, which is JSON for now, and then passing the configuration and the start, which is earliest or latest according to whatever you're going to send as an option. So all you need to do to subscribe through Python code is just these 2 lines. This one is what I'm actually doing with the message I received. So let's try here to first build our application. I'm going to copy this here. error. Bryce, can you please remove the Visual Studio? Okay, I think I might need to use a different command. I think it's if you create your own environment and running it in your environment, I think it's going to work better. Okay, so I think
Shereen, I think it is installed. We have off email.
okay. I think we can move to the next step then. Is there any questions so far? Did it work well with you or not?
Perhaps hit the yes check mark if you've followed along to this point.
Hit the what?
I asked everyone to click on yes reaction on that check mark.
Yeah. Okay.
Yeah, it looks like a number of people managed to get to here. Good.
Okay. No no's. That's a good sign. Okay, so I'm going to receive an email here. You have to add your own email address. I'm going to use Bryce's email since my email is just stacked of emails of trying this out. So if you now enter, you will get a message that says email sent. Okay, that's cool. And voila, here is the message. Okay, did everyone receive the message? And please note that the email might go to your junk email box. Please click yes if you received it.
And there's the unknown as well about whether Google is going to kill us for spamming. That's something we couldn't really test in advance very easily.
Yeah, hopefully it doesn't, since we are using application password, not the password for the email itself. So it should be accepting such things. So this is for the email application we currently have. You can play around using the template, building your own application, and it should be going smoothly. So just to summarize what we did today in the demo, as you have seen, our Hop client provides you with a direct way to have a pop-up system along with the capability of integrating with Hop client.
Can you go onto the email and see her?
Okay. So it helps you create a real-life application with just very simple commands using our templates, and you will be ready to go. One last thing is, as a personal experience with the template, me and Rich Polsky at UCSB used this template to create an alert system for a real-life IoT application. It actually saves us a lot of time. So instead of focusing on building the pop-up system infrastructure, you'll be focusing on your application itself. So it was a good choice for us. I think I'll be handing now the mic to Mario
Thanks, Shereen. Just want to open it up for questions for you and Bryce about the demo or anything related. I see Derek has his hand up.
Thanks, Shereen. That was great. My question is, what is the cookie cutter package and what is it doing for us in this context? I didn't quite catch that.
Okay, the cookie cutter is actually a command line interface tool. It's used to create an application boilerplate from a template. So you give it like parameters, like I give it an email, and it creates you the application. You have to set the files and all the stuff you have in your project. So it will be able to just substitute with your data, like your application name, for instance, your email, your name, your author name, and this stuff in the application files. So it actually helps you so much to build an application from a template.
Okay, thanks.
You're welcome.
I see Leo has his hand up.
Yeah, well, I guess my comments and questions, I've been typing in the chat a lot about them, but I guess I'm more excited to see a demo of sending and receiving machine readable data. And I guess I mean, I'd like to hear about, you know, I mean, you have a demo here of sending view events and emails over Kafka. That's not, I mean, I think that to realize the full potential of Kafka, you'd want to you'd want to embrace sort of the Avro and JSON format so that you can take advantage of all the other infrastructure that's part of the Kafka and Confluent ecosystem. So I guess you know, have you thought about whether you'd use, I mean, we at NASA, I've been encouraging my colleagues to look at some of the Confluent offerings and in particular things like Kafka Connect for you know, persisting Avro packets to a database. So I mean, have you thought about like if there are sort of sensible but opinionated decisions that you could make that would, you know, make it trivial to you know, to warehouse alerts that have already been sent? And have you thought about whether I mean, you have you thought about whether you would encourage people to put schema for alerts that they're generating in a schema registry, or if you or if the best practices for, you know, setting up a new set of Kafka topics for a new facility would be some, you know, some slightly less formal specification of the alert contents?
So I think there are a couple of questions there, and the one by Jason, I see that Bryce already has something to show if you hit enter on that. Oh, but are we sending new messages to that topic? So all right, while we're waiting for a message to arrive, think one of the things we don't want to bring across incorrectly is that we're sending kind of text or unformatted text over Kafka. Everything that went over the wire is actually JSON already, and we just display it as text just for ease of use and ease of this demo. So you're completely right, Leo, that the whole point of this system is to be able to send arbitrary messages from machine readable, from machine to machine. And for this demo, we just, the way we display them is in human readable format, but on the wire, they're all machine readable. The second question about Avro versus JSON and all the other formats, the underlying libraries, excuse me, the underlying libraries are actually fairly format agnostic. There's in the API, there's actually a keyword argument called format. We potentially could, if we defined a schema, an Avro schema for this, for the let's say the GCN format, we could flip that. We could set that argument and have the library pass Avro alerts around rather than JSON. So this is one of the advantages of kind of using the Hop client library rather than others, because we maintain a separation between the serialization format and the data model that's being serialized to the maximum possible extent. So that is something that we're looking to do in the future. But right now for this demo, we really try to make it simple. And I'm sorry if it seemed like we're doing something that's perhaps too simple for folks who already know a lot about this. The question about databases, is anyone from LCO on the call? Maybe Andy, do you want to say something about how we're planning to store the alerts into the database? Or maybe Adam, if Andy's not around.
Yeah, so David Collum and Lindy Lindstrom at LCO are looking at this with me, but we're just at the point of building up a sort of prototype where we just take in Swift, and I think maybe we're also going to. I think initially Swift machine readable notices and turn them into a format that'll go into a relational database. But we're not committing to that schema going forward. But this is just a sort of a feasibility test and designing a public API that people would be able to hit to get information from the database. And the public API will be probably closer to the final version than the database, which will be hidden anyway from a typical machine user. So yeah, it's early days on that, but we have started it.
I mean, I guess.
Actually, Leo, can I tell you just a little bit about something specific we did here? So one decision we made, which may be wrong, but just to get us to a milestone, was to separate the concept of the connectors, so the plumbing, from the content that would be pushed down the stream. And in particular, we were a little nervous to start to go down the road of trying to define a specification of any kind for the content early on, and when we know that many years of effort has gone into, for example, VO events. But what I'm saying there's no, I'm not taking any side on the best approach. The one thing that I think that we figured we learned as a community from VO events was that separating your container from your contents is very important. And we're sort of maybe taking that abstraction one layer further for now, which is to also take the plumbing and separate it from the container for the data and separate it from the content that's inside of the container. We've had a few conversations with the team in Europe that's been emphasizing VO event, the IVOA team. and have sort of started to explore discussions there. But we feel like that's a much bigger discussion item than SCIMMA. And really, while we'll definitely try to help facilitate and get it moving quickly, because we kind of want this to be ready and usable in the next year or so. I think as I say, we don't want to end up spending a great deal of time on that before we have a system that you can actually push it down the pipe and make something usable right out of the gate.
I mean, okay, but to me, that's not the, I don't see that as the reason why VO event ultimately never had large scale adoption. I think that the reason is, a large part of it is simply that, XML itself has, largely fallen out of favor because it's fundamentally very verbose. And my thinking is that, the by far the biggest producer and user of Kafka in astronomy is going to be the Vera Rubin Observatory. And I figure that it makes sense to try to emulate what what they are doing, because they are the biggest user and they're going to have the biggest number of consumers, far more users than there are users of GCN right now. And so wouldn't you rather, instead of taking VO events or email formatted GCN notices and sending them over Kafka, wouldn't you rather receive Avro packets that describe Swift and Fermi alerts? And if you follow that logic that that the multi-messenger community should automatically adopt the same formats that VRO is adopting, then the fact that you're deciding to use, broadly speaking, JSON or one of many things that can be bidirectionally converted without loss to JSON, such as Avro or BSON or anything like that, rather than XML, means that you don't have to do extra work to design the database where you warehouse the alerts, because the schema for the database is exactly the same as the schema for the alerts. Doesn't all that make sense? There's the rest of this. There's this whole ecosystem around Kafka it's not Kafka. Just adopting Kafka itself and none of the rest of it doesn't make a whole lot of sense to me.
I think we can possibly take this discussion offline, just not to occupy all the rest of the time with it. But I hear what you're saying, Leo, and I think we're doing that. In fact, we're all of this, like Spencer, who's one of our Kafka developers, is actually the lead on the Rubin Observatory team for developing the Kafka services and that entire system, and we're actually sharing it down to the code level. So we're kind of going beyond emulating what Rubin does. We're essentially building the same system, or we're working with them to make this another prong of the same functionality system. So I think what the confusion here might just arise from the way we structured this demo. We tried to make it more human readable, to make it kind of more accessible to a broader community. But underneath, what we're trying to do is do exactly what you're suggesting, to have a system that's capable of shuttling binary encoded messages with strong schema if the user desires such, that's compatible with what Rubin is doing. And I think with a little bit more offline discussion, I think we can clarify that.
Yeah, if I could just say, sorry, Leo, from the very beginning, we decided to separate the issue of format from the issue of like the cyber infrastructure to run the messaging. So when we're building Hopskotch, we weren't initially making assumptions about what sort of messages people will send, even though we know what we would like people to send. And as we do move more into formats, we will be trying to, you know, this is the direction that most of the multi-message astronomy community, astrophysics community would like to go. So we, you know, to help them go in that direction, but not at the expense of telling a bunch of people that what they're already doing is wrong and they have to re-implement, or they're out. You know, so we're designing in the context that we're currently in and hoping to be going in the direction I think we all agree that we ought to go.
Oh, okay, sorry for taking so much of the airtime, but I guess, I mean, related to that, I mean, I've been pushing very strongly at Goddard to adopt Kafka and Avro deeply within GCN, and I don't know if we will or not, but I mean, if we were to work toward, you know, sending, you know, actually having Avro as one of the output formats of GCN for notices, not for circulars, and also worked toward, you know, encouraging, you know, future missions to have Avro as their native, you know, alert format rather than VO event or you know, or email formatted notices. Would that be stepping on your toes? Or I mean, how do we do this in a way that we're not duplicating effort?
If I could, so Leo, as you know, we already arranged a meeting with Judith Rakusin and also Scott and yourself and others that were there. So from our side, we're really doing, we really don't want to do any replacements. And so I think this sounds like a great place to link up. So we're going to have the monthly meetings initially, but as I said yesterday, our goal is to figure out ways to broaden and make it more community building of various tools. So I think there's just a great opportunity here, given that you're encouraging a move that direction. It's consistent with our roadmap. And so let's take what we have here for now and finish out the demo, but bear in mind that what we actually want to do is, starting as soon as possible, work together to make that, you know, to make these things basically transparent, and so that the user doesn't have to care about what's doing the middle layer, and everything works smoothly and efficiently.
Okay, thanks. I'm sorry, I didn't realize the demo wasn't over.
It may be, actually. I'm sorry. I should have been careful about saying that. Anyway, back to I guess either Adam or Mario, who's chairing the session, and maybe. And by the way, I'm not Leo. We should continue the conversation. Let me make sure that you get that message from me. I really mean this is a great conversation to continue.
Well, thank you. And I mean, I don't want to. I mean, the flip side is that if there's something that we are thinking of doing that SCIMMA May is already going to do, we need to make sure that we don't do that as well.
Yeah, no, I think Mario would agree that one of the real benefits of this has been, you know, some of the sort of feature ideas that people have been bringing up, and also potential work as you've been doing there. So. Also, I would say now, if anybody has other things that they think should be incorporated, you know, we can probably imagine a vast list of things that could be incorporated, but our prioritization comes from community interest. So if people do have any questions about whether it can do a particular thing, or whether or not we plan to include something, then please do ask now.
Are there any other questions while we still have Bryce sharing his screen and potentially can show us the code or something else involving the demos? So if there aren't any, then let me grab the screen share back and just show you one or two last slides with sort of where we're thinking about taking this next. You'll just give me one brief moment. Okay, so before I continue, thank you both Shereen and Bryce for the demo and the entire team for preparing all of this. I think, again, I want to emphasize that what you're looking at is none of this existed about 2.5 months ago, and including the team, we've really bootstrapped the whole thing quite recently. And so you can expect a lot more over the next 6 to 12 months. So that is what I wanted to talk about here, just to mention here. Like, what are we looking at through the end of the year and then into 2021? So I think one of the things we want to do is deliver a stable and reliable, though still prototype Hopskotch service. So the server you just used today, we're going to shut it down after this demo because it's I don't know, everybody had the same password and it's not well secured, et cetera. We took a lot of shortcuts to make this demo possible that production service simply cannot do. So that's what we want to do going forward, make this into something that where one will be able to log in with their university credentials like we saw yesterday. And then also create a couple of connectors to existing services that will funnel all of those into Hopskotch, simply as a long-running prototype service that we can use to experiment with. One of the things we also were interested in looking at is Hopskotch is really a message passing system, so it doesn't have to be limited to GCNs, ATELs, TNS, via events, etc. But if your system needs to pass a message to somewhere else or needs to publish some information, it can be used for that as well. So one of the things we're thinking about is what about telescope pointing and scheduling information exchange? Those kinds of things might be quite useful as well and lend themselves to this type of PubSub communication. Now, one of the big things about, or one of the points of these types of systems is topics into which data streams in. You might have processors operating on those topics, say ingesting GCNs, ATELs, TNSs, doing something with them, and then injecting the results onto a different topic. Something as simple as taking all of these and converting them into some unified data model to make it easy for downstream clients to parse and utilize. This is something that we heard would be quite useful for example, treasure map. The kinds of things that Neil talked about 2 days ago, so translation from unstructured to structured formats, and then beyond these things, real astronomy and astrophysics applications. So taking the data coming in, perhaps running models, running model fitting on them, injecting some inference results into those packets, and then sending them, publishing them back on a stream. So these are the kinds of things we'd like to start experimenting with. IAM integration, I already mentioned that. Then everything that goes through the system right now, once it expires out of the topics is forgotten, we want to eventually start creating, keeping all those in a database of received messages. The big challenge here are going to be access rights. So we want to have the ability for someone to add value-added data that are perhaps viewable only to their collaboration, not to everyone. How is that handled in the database? those are the kinds of technical issues to look forward to, or I guess to be worried about, and to look forward to solving. And then all of the, especially the database side, will require a web interface and an integration with Tom's and Treasure Map. So this is sort of where we're going in the long run. A lot of this is, or I would say short to medium term, and a lot of this is going to be informed and changed based on feedback we get from meetings like this and similar meetings going forward. So I'm going to stop at this slide that sort of lists the key URLs and how to get involved. We also have a GitHub organization, SCIMMA. If you've encountered any problems here, feel free to go to github.com/SCIMMA and then open an issue on honestly any one of the repositories. We'll make sure it gets attached to the right repository if it's not clear which one to use. And yes, we're very interested in feedback and talking to the community, understanding what can we do to make the system address any specific needs, either any needs that we've already identified or needs that you can think of that we might not be aware of yet. So I'll stop here and I'll hand it back to Adam, and then we can take questions.
Yeah. So thanks, Marion, and Spencer just made a point that people don't. We would like to hear your requests for features and thoughts, as Mary just said, and they don't have to come literally now if they haven't occurred to you. Please do email us. Please do attend our once monthly public telecons. It'll be the first Tuesday of June, which I think is the 2nd. Yes, and obviously the more responsive we can be to community needs, the better the end product for all of us. As Bryce pointed out, the SCIMMA developers will be hanging around after my final remarks, and so if you do have more technical questions you would like to ask or talk about collaborations or more questions, then please do hang around, even though the demo part is finished. But thank you ever so much for attending the 3 days of this workshop, and we will be sending you a survey to ask your opinions about what we should be doing going forward, and workshop organization and those matters soon. And it really will be a very brief survey. It won't take you terribly long. So thanks to everyone for attending. Thanks to Shereen and Bryce for running through this, and for Mario for putting everything in its context.